Just got a few more seconds, we'll get started here, guys. Okay, greetings everybody. My name is Liam Randall, and I'm here to talk about incident response with the Bro platform today. So many of you guys know I've been working on Bro for a while. So let's talk about what we're going to do today. We're going to start out with a quick introduction of Bro. Then we're going to talk about incident response in general and what some of the work products are, the tools that you use. We'll do a quick dive down on the core of Bro and look at how Bro uses documents. And then we've got a ton of code to demo. And I'm not going to be able to show all the code. I always write way more code that I could show on stage. But it'll all be up on my GitHub repository at criticalstack.com. Then we're going to look at SQL injection through the eyes of Bro. There's my kids right up here cheering for me. And then we're going to tell a little story, which is my favorite part of today's exercise, because I think that we'll wrap it all up and put it together, and you'll see how this actually is not an evolutionary product, but a dramatically revolutionary product. And then we'll end with Bro jokes, which is always a fun part of the day. So this is me. If you're going to live tweet today's event, if you'd please tweet to hectaman, Bro IDS, and Critical Stack, that would be awesome. You can follow me on Twitter and find out about when the next Bro training is available. I have a pretty busy schedule right now with Bro. Next month, I'll be out at B-Sides DC teaching free classes. I'll be down at Houston SecCon, MOG in Boston, and then FlowCon, S4, MOG, and ShmooCon all the way through January. So I try to put a ton of content out there for you guys to get into Bro very easily. So what is our purpose today? So today we're really going to talk about leveraging some of these advanced workflows in order to increase your team's productivity. And we can do that while reducing the amount of time spent on incidents. So everybody always wants to be more efficient. We're in this sort of growth cycle right now in security where we have way more incidents than we can handle. So let's talk a little bit about the current incident response process. Typically, if you're at a large organization, you'll have this codified, or perhaps you have some contractual or legal thing that you need to follow, like a NIST standard on how you're going to handle your incidents, and you'll have a workflow. And you think about this as a life cycle. And it's your job, perhaps, as an incident responder to actually do these things on this cycle. And a lot of times, it essentially revolves around finding truth in your network, like determining what actually happened. So in your network right now, you have these racks full of crap. These are the things that generate logs and alerts. Some of them tell you things. Whether or not they're useful things remains to be seen. These are the kind of things that you'll typically see popping out in your network. You'll get alert data like we saw a bad thing, right? We have a signature match, and then you need to basically verify, is that true or not? Is that something that actually happened? You might have some sort of a behavior piece where you have users calling in and saying, oh, something weird is happening. I need to determine this. And you would pivot to these tools, and then you would try to discover what the truth is. And then you also have this increasingly granular steps towards reality, where you start at a high level abstraction, and then you move towards things like full PCAP to really understand and make a decision about what's going on. And this may be your daily workflow. You're taking out the output of all these tools and you're putting it into like ArcSight, or maybe you're using Security Onion with Elza, or something along those lines, but you have this big log aggregation tool. And your job is then to handle these things, and for each item in the list, basically say, is this true or not? What happened? Your work products that you'll create will be things like maps and so forth. And there are these steps in this process as you move down, as you move away from like a packet capture, you're really moving away from reality. At some level, and we'll talk about this later, these increasing levels of abstraction sometimes complicate the process. When you just say that a user visited a domain, that doesn't really tell you anything. That Liam visited badguy.com. There isn't a context to that, like what happened while you were there. So those are the kind of things that we struggle with when we're trying to determine these different layers of abstractions. Generally, whether you're at a Fortune 20 or you're at, a small business, you have these 3 work products that you'll create when you handle these incidents. So today we'll sort of revolve our timeline around generating maps, generating a timeline of the incident, what happened and when, a chronological point of view, and then the ability to explain it in a story. In human terms, what happened? A user got hit in a drive-by download, and then there was an infection on their workstation, and so forth. So my tool of choice for working through these things has been Bro for a long time. And it really immediately resonated with me. Actually, one of the first large networks I deployed Bro on, the gentleman's here that actually hired me to do so. So Keith, thank you again. I'd been using Bro at a lot of places, but you really believed in it 4 or 5 years ago at this point. So that was really cool. So we talk about Bro being 3 things. And this is the hardest part about really understanding Bro, is that you have this platform that you install on commodity x86 servers. So these are the Dell boxes that Work makes you buy. This is Supermicro stuff. And Bro can be installed on 1 or more boxes. And you essentially are mapping network traffic in the amount of megabits per second to CPU cores. And then Bro does its things. On top of this platform, there is a programming language. It's a Turing-complete programming language. It's called the Bro programming language. It's funded by the National Science Foundation and developed by a team of really bright guys at the National Center for Supercomputing Applications in Urbana-Champaign, Illinois, and Berkeley, California at the International Computer Science Institute. Then logically, on top of this platform, you run apps. So think about this thing right here, what you have in your hand. 20 years ago, you would have a notepad and a telephone and all of these other things. And what Bro gives you the ability to do through this flexible programming language is sort of solve all kinds of problems. Compliancy type problems, vulnerability, a threat grid that has some people here, and they were using Bro to feed, to extract files out of the network and automatically submit them for sandbox analysis. And they actually shared some code. I'll clear it with them to make sure I can post it on my GitHub as well for doing that integration. Bro is designed with security purposes in mind, but you think back to those racks of crap, you can do all those kinds of things. And today we're going to talk about this particular use case of at an incident, how do we take these tools and then leverage them to speed up that workflow? So this is kind of that high-level mental map to the space. You get the platform up and running, you feed it network traffic, and then you install applications on top of it. So we talk about Bro being made of these 3 layers. It's easy to talk about Bro as doing 3 things. So the first thing that Bro does is, and you see I spilled my water, it generates logs. Real quick, this is sort of the fit for Bro on the network. It is, I spilled it when I was dancing. That's what I did. There's like water all over the place. So this is Bro's point of view. So we're installing Bro on the network. You're going to give it both sides of the conversation. And essentially, the real insight here is that we're attacking the network at its weakest point. The internet works because we've standardized on these communication protocols. My laptop and my telephone and these IP TV video cameras in here, and your laptops on wireless, your tablets. Hey guys. Oh God, what are you doing?
Ice, baby.
I thought it was the ice bucket challenge. I was like, no, not on my laptop.
Let's kick it.
All right, thank you guys.
No, you have to finish it.
I'll finish it. I have like 60 slides to get through.
Yeah, keep drinking, man.
Hey, thanks, guys. All right, big hand for the goons here, jumping in to really get me going here in DerbyCon style. And I got to say, hair of the dog, I was in the weeds this morning after all that cherry DOS. For those at home that didn't make it to DerbyCon, cherry DOS is DDoS is the distributed denial of sobriety that I make and then I bring to conferences. So where were we? Bro is, attacking the network at its weakest point. The standardization on communication protocols gives us the ability to inspect all the things. So the logs that come out of Bro are different than some of the things that you find in those racks of crap because it's the ground truth. If you're speaking TCP/IP and the protocols that Bro understands, then you're looking at all the logs from all the things, all the time, right? If it was on for 1 day, for 1 minute, and then turned off and was never there again, it's still going to be in your Bro log. So it's just this passive ear to the ground all the time. So Bro's first product thing that you make, Bro, this is, another way of saying this. This is how Bro communicates with you. Not through water drops on my keyboard. For every protocol that Bro understands, we'll write logs. So for example, there's a DHCP.log, and a DNS.log, and an HTTP.log, and a con.log. And you can think of these logs like a slice of cake, if you will. You have this crispy connection layer crust, that has a TCP, UDP, ICMP mock flows in it. Then you also have this application layer like HTTP. Then on top of that, there will be these meta layers like files.log that give you the ability to sort of understand. So for any given connection or any given file, you can think about taking a slice of that cake, show me the logs from each layer here, that give you a meta abstraction of the flows for that period. And we're going to look at some of these Bro logs. Bro can also generate alert type logs where Bro is telling you, I saw a bad thing, right? Then the final thing that Bro can do is basically actions, and this is the biggest category. You can basically tell Bro to extract all the executables and then submit them to Cuckoobox for you. This is by far the most powerful point of view, but the big idea here is that, Bro is around for 20 years. It's turned 20 this year, and for the first 17 or 16, almost all the users just thought about Bro as this sausage machine. I put traffic in this side over here, and then all these logs and alerts come out on this side. But that's not the big story here, guys. The big story is that this traffic, the sausage machine itself can easily be reconfigured and changed to do whatever you want. So the scripts that I'm going to write today, when we look at the source code, will be incredibly short because Bro's just providing us with these big logic blocks, if you will. When you really start to get in and look at these things. So let's start. Let's move forward then by looking at a protocol state machine. So for every protocol out there, you'll find that there are these RFCs published, and this is a high-level description of of how the protocol should operate. Pardon me. That's what I get for chugging a beer on stage. And this is an area where there's a ton of opportunity for misunderstanding. Would be a nice way to put it. The protocol RFCs themselves are full of things like may or can or should, and these RFCs are implemented by different operators all over the place. So as a demonstration here, let's take a look at the protocol state machine for HTTP. But before we do that, by show of hands, just divide yourselves into two categories. If you're one of my blue team brothers, just raise your hand. Excellent. Good, nice representation out here today, guys. And if you're on the red team, can you raise your hand? Oh, good. Okay, so I'll ask you guys later to put your fingers in your ears. Okay, but let's, I don't want to give away all my tricks, right? So let's first look at a yummy piece of Bro cake. Okay, so can you guys read that in the back there? Okay, so you can think about this as showing, moving up from the packet layer to the flow layer. Each individual log line represents perhaps thousands of packets over a flow. So here, for example, we're looking at the connection layer, and you can see that you have this nice connection ID. And if you're a database person, this is what you can think of like a key value. You could use this value to pivot from one layer to the next layer, much like you would do in a database. Now, there is information here about the originating host and the responding host, about the dynamically detected protocol here, what port it was running on, and so forth. So at the connection layer log, connection layer details are represented here, and that would make sense, right? And there's all sorts of information about, who sinned, who act, did the originator of the connection. We don't say client server in Bro because the semantics don't really hold for a lot of protocols. When you think about like what really happens with FTP or an SMTP, I could originate a connection to Coleman, for example, and then I could issue the turn command, and then that would instruct Coleman as an SMTP server to deliver mail to me. Who's really the client server there? The semantics fall apart really quickly. So we always say connection originators and connection responders because that's sort of the deviation. Who sinned, who sin act. That there's all this detail here that's very helpful. So let's step up to the next layer of Bro cake here. Now you can see that I was looking at the http.log. So if there were, and I've only extracted one connection here to keep it simple on the screen, but we could very easily do, let's see. Nope, I didn't cut and paste it while I was in there. Hold on. If you were looking at a lot of logs, say in an incident, you could take that log there and you could, I didn't list that, so I should sorry about that. have this a yummy piece of a bro cake. And actually I've got and you can see there's every log line where you see that connection ID represented there. Let's step up a layer to the http.log, all right? Okay, so here in the http.log, you can see that using database language again, that these log fields have been selectively denormalized. Now, if these logs were designed just for consumption by a computer, you would know that you could do like a join between the two tables, if you will here, the con.log and the http.log, and you could pull that information out. But these logs are designed for you guys as human beings to speed up this process. You know, we've moved away from the packet layer where, you know, packets are down here. Alerts are way up here. Alerts are, 0.001% of granularity. And we're in this middle layer now where you can sort of get a semantic understanding of, okay, on this HTTP request, there's only one transaction issued. It was a GET request to s0.cybercity.org. There's the URI. The client-controlled user agent over here, this will be my client side of the table, and this can be my server side of the table, was curl. And the server passed back some information, including a file that was dynamically detected as an image PNG. Now, there's also this meta layer here, this files.log layer, and we'll explore this more in actually real detail here. That is just this abstraction that rides on top of just what were all the files that were transferred in that session. Because sometimes when you're dealing with these incidents, you don't really care about the underlying details, what was the transport that it moved over. You just want to know what's the hash of the file and so forth. So these files, when we're looking at these things, these protocols, remember, we started with the RFC now, you can think about every protocol moving through a protocol state machine. And what I've done here with Bro is I've extracted all the internal events here. And the details may be above or below some of you, but I want to just walk through a sample protocol state machine. So I have my two little helpers here. I was going to ask my boys to come up here. Guys, you want to sit up on the stage? No? Okay. Well, I have proxies for you. I have Jumping Jane over here. This will be our server side, and I have a client side over here too, these little guys. And so this will be my server side when I'm talking as the server, and this is the client side of the transaction. So as Bro's tracking these protocols, it basically gives you insight into these two hosts as they move through the protocol state machine. So Bro gives you these events, it throws it up into script land, and you can hook that event as 1, 0, or as many times as you want. And as far as relative to the amount of data, you have 100% of the data down there as full PCAPs. Bro can extract from 0 to 100% of the data. You could extract all the files, and that's what we're going to move towards here in a second. So you have this ability to, on the fly, make decisions about what you're going to extract. Now, obviously, Bro is not a time machine, so if you don't start an extraction at the beginning of a file, you're not going to get it out. But let's walk down through this protocol state machine here. So the client, issues a new connection. SYN, server comes back and sends exit. The Bro tells you that the connection has been established. There's our SYNAC. Then Bro tells you that I've dynamically detected that this is analyzer HTTP, right? And you know that this is now valid RFC compliant HTTP. Bro's attached to the connection and is processing it. And then it starts to diagnose the protocol state machine components and then give you insight and access to those events. So the client says HTTP request server, hello, HTTP request, give me an image please. I'm speaking version 1.1. And then the server comes back. Actually, the client's still talking here. Bro says, okay, we're going to begin an entity. Now, there were many events that could be thrown by both clients and from servers. And we distinguish the difference between the two with a flag. And you'll say, is this from the originator or not? And you'll see this flag switch in just a second. So the first thing that the client says is, HTTP header, it says user agent is curl 7.340. So boom, there's an event. If you wanted to test that for something, you could test that at that time. Then it says host s0cybercity.org. Then it says I'll accept star.star. And it moves through this machine until it is the server's turn. Now, Bro gives you access to these things to extract and can pull them out. But the server, then the client says, hey, I'm done speaking HTTP. And the server comes back and it says HTTP reply, 1.1, 200, version OK. And then it says begin entity, which is a component of the HTTP protocol state machine where we're explaining server header entities and body entities, essentially. So the server then begins, and the server issues its headers. It says content type, image PNG. Now, this is what the server is reporting. Later, when the file is transferred, Bro will do the extraction or will test that file itself on the fly and tell you what the MIME type is. And do servers lie? Do they say, I'm going to give you one thing and then give you an executable? Sure they do. And it's easy for Bro to just do a comparison between those two things and tell you. So the server says, here's more headers. Here's content length, 30K. Connection, keep alive. Server, Nginx. Date, February 11th. Whom. Cache control. This was expires, as it goes through. So you really start to see the reality of these protocols. And there is a different protocol state machine for every protocol. Like the SSL TLS one looks different than this. It's just because it follows a different protocol state machine. Except ranges. I take bytes. This is still except ranges, I take bytes. E-tag, I don't even know what the E-tag is, but there's the E-tag. Last modified, X origin type, X cache, a miss from CloudFront, via, and all of these other fields here. Then we see the server actually transfer down the file itself. Bro gives you access to the file. You can decide now what you want to do with it. And then the message is done. And then we see Bro here is now saying that this PCAP has ended because I was replaying from the command line. So any given time, Bro is handling thousands of these events, depending on the scale, the speed, the number of Bro processes that you have going on. So this is sort of insight into the internals of what's happening there. Okay. So as we're moving through these protocol state machines, we find lots of those deviations. And as both red teams and blue teams know, a lot of exploitation is simply taking advantage of those subtle nuances in the protocol state machine. So let's do an example now where we look at traffic that's a little bit different. In this case, what I'm doing as the client, I'm going to issue the host header twice. Does anybody know if by the HTTP RFC, if you're allowed to issue the same header twice? Is that valid or not? It doesn't say. It says you have to have a host header, but it doesn't say you may only have one that host headers have to, or that headers have to be unique. So when you're doing, you're executing all these attack tools, there are, I kind of in my mental map of the landscape, I divide these attacks into a couple different categories. And one of the more common categories is sort of abuse of the protocol state machine right here. So let's look at an example where we are abusing this protocol state machine. And here I'm going to actually show you where there's sort of this default weakness in Bro. And this is sort of a part of a larger understanding that I want you guys to have about tools in general. Not just Bro, but every tool. It's this. Logs are lies. Every log. It's a lie in the same way that a map is a lie. When you go out to, we're in Kentucky, right? Otter Creek State Park, out there off the other side of the expressway. And you open up your map, it is a representation of the underlying data. And every log that you have throughout this process is in certain respects a lie, because it's not the 100% reality underneath here. So here I've taken this PCAP, and when my server here was, or when my client was talking, actually let's look at what the client actually said first. We can do that. So I'm in less, so I'll do a / see down at the bottom left here, and then I'll just search for a host real quick, and it should take me right to the first instance of host. So here's what you can see. I actually used curl, I think, or wget on the command line, and I just specified the -- header name twice, and I sent the host twice here. Now, this could be, so the question is that all of these logging products, what are they all going to say? How does Apache handle this if only one of the servers is there? How does Apache handle it if two of the servers are there? How does Nginx handle it? You sort of, once you get away from this reality of this messy traffic out there, you start to get into this gray area. And people are building these big castles in the sky on top of this gray area. And it is a swamp, right? You're looking through your SIM and you're saying, well, the log says that this is where they went to visit. So let's see what Bro would say in this case. All right. Now, this server on the other end, we know it was running Nginx, handled this request just fine. And it passed me down the log. And so first I requested the correct site that it actually hosted. I suspect had I sent the second, it would have errored out there. But let's see how Bro actually handled that. So in the default Bro logs, you can see that Bro logs all the data here. What happened? Here's the remote host. Except Bro's now showing me the second host header. So now that's an easy thing to detect in Bro. And I have a Bro script that not only will watch for duplicate host headers, and Shirikata has a rule that does that, so it's not just a Bro specific capability here. And I've also added a little Bro script that basically dumps a vector of, or like an array, an old school programming language here, of all of the headers. So was actually using the script very recently on the Bash vulnerability to monitor for the different types of attacks that people were doing. I actually, you could take this and create a new log and call it http_header.log and just sort of research your network. There's probably some significant offensive capabilities for those of you that are on the other side of the table there, on the red side, to start leveraging these tools, because you can profile and log things very quickly. And also, have the reporting all generated in a workflow. And you can see here are the server header flows here. It was the exact same server. So when we start to realize how flaky all this stuff is, oh man. Oh, that's the wrong presentation. Sorry, that was ArchCon. Okay, we're back. Good. So when we start to realize how flaky all of this stuff really is, there's no choice now but to believe that logs are lies. That ultimately there's this realization that your job then becomes, when you get an alert, to tell a story, to determine what actually happened. And if you've ever tuned a modern IDS, you know how chatty and false positive some of these things can be when you're looking through these things. So let's step back into the Bro world, and let's talk about one of those meta abstraction layers that Bro is really good at doing. And let's talk about this files framework, because I thought the most effective demonstration that we could do today would be to stop thinking about our network as a series of connections and flows, and to start thinking about it as a bunch of files moving around, because that is an interesting perspective that can sometimes help us to quickly understand and get to the truth, right? I'll discard all of the packet data, the headers, and essentially just think about what are the documents that these servers are exchanging with each other. So the files framework is this wonderful capability, and let's compare it real quick to another abstraction that's been in Bro for a long time, the protocol abstraction layer. In Bro, the nice thing about all of these events, if we pull one of these back up here again, let me just pull up, right, is that when this event fires, like HTTP request or the details, it's as many details that are not necessary at that time are extracted away from. For example, do you really care what the protocol? Hold on, was it let me pull up my picture. There it is. Right. When that HTTP request fires, do you care if it was going over IPv4 or IPv6? Do you care if it were embedded or nested inside a Teredo tunnel or MPLS? If you care, then you can care about that in scriptland. Do you care what port that HTTP was running on? Or is it your job as you're implementing this compliancy thing or this security thing or this whatever this thing is that you're doing on your network, is your job simply to apply a policy? And by abstracting away from all of these underlying details, but giving you the ability to care about them if you choose to, it gives you the capability to deploy very powerful and effective scripts. If you wanted to log all of the HTTP requests, which Bro does by default, by the way, it's sitting out there listening. And if somebody spins up an HTTP server in a Teredo tunnel over IPv6, that same HTTP traffic still goes out there. One of the big networks I deployed this on a while ago, we were testing the towers themselves to see the cellular towers out in the field to see if there were what was going on, who was accessing the data plane. And so out in telco land, we had some really sophisticated layers of traffic. You'd have towers running IPv6, and on top of that, you would have like a laptop with a CDMA card. Logically, on the network, it presents itself as a GPRS tunneling protocol, so GTP. Then you could have like your laptop with an IPv4 address that speaks UDP to Microsoft using the Teredo protocol to get an IPv6 address. To then maybe open up a TCP connection to cybercity.biz to speak HTTP. And this HTTP traffic up here shows up in that http.log. And for me, this was when I decided to essentially quit all of the other things I did and just work exclusively on Bro, right? I was like, holy crap. And we were doing that at 10 gig, by the way, because you have this meta abstraction. So let's apply that to files as they're moving around the network. Well, real quick, so let's do a sample policy. So for HTTP headers, for example, you may just want to test to see if Java was the user agent. You know, because maybe you're looking to see what are all the Java things on my network, right? Do we have, and this isn't just the devices in Active Directory. This isn't just the traditional PCs. Maybe you have a SCADA controller that has Java on it. It happens. Or a telephone system that has Java on it. This is the ground truth. So let's apply that same meta abstraction to the concept of files moving around your network. So, when you're thinking about files coming in, the base abstraction here isn't the protocol that it came in over. It doesn't really matter if it was a DCC transfer or did this file come in. If we think about PDFs, for example, do you care if this PDF was downloaded via web browser in a drive-by? Do you care if it came in via an email? You probably don't. You just want this ability to say that, boom, there's a new file. Do you even care what direction it came in, right? If you care, then you would say, like, if you only wanted to look at stuff from that originator here, that client, you could say, new file, is this from the originator? If it is, then do whatever else you want to do. Or is it not from the originator? Test the MIME type in details. So it's those meta abstractions that give us this capability now that we could use in the incident response process just as a use case, for example, to dramatically accelerate our understanding of these things. So let's look at a sample policy. So this policy, for example, extracts all the things in all the directions on all the protocols, saves them out the disk. That's it. When we talk about those Bro apps, I think people get intimidated sometimes because they're like, man, I don't want to learn another programming language. But I assure you that this programming language is unlike anything that you've ever worked with before. It's high-level logic blocks right here. So this would save everything out to disk here. And if we only wanted to then say save the executables, we would simply just add a little if statement and say, is there a MIME type? And if there is a MIME type, is it an application DOS exec? And now we're saving all the application DOS execs out with this policy in both directions on all the protocols. So let's walk through a piece of Bro cake now with this new meta abstraction layer, right? We got this crispy connection layer crust here, con.log. And we have these connection IDs that we could use now to pivot up to http.log, right? And in http.log, I can now link in a new type of a file ID. And the file IDs now actually begin with the letter F, capital F here. Connections begin with capital C for connection. To link these things together. So we can even abstract away from all of the underlying details and just think about files in the network, and then start to pivot these things out. And then we have this other log just stacked right on top. The files.log then is now gives us the ability to pivot back to flow or flows, plural here. If you look, this is connection UIDs that it came from, because files could be transferred over multiple connections as these things are coming down. So from a forensic logging perspective then, thinking about the Bro cake analogy, we think about the notices that Bro would generate. I observed this file hash here, this example notice is a hit to the team malware hash registry. So think of it like a sprinkle or a cherry on that piece of cake now for this, all the details from this one particular flow here, connection, HTTP, files, and then a notice. It gives us the ability to present this information in a pretty novel way. The team malware hash registry script is built-in and turned on by default. The VirusTotal script, I think, is up in the Git repo, and you would need to have VirusTotal API access in order to fire that off, which is quite expensive. I don't know if I can say how expensive, but I've seen some big ranges there. Yeah. All right. So let's look at this, a pretty important detail about this. Now, if you've worked with other tools before, and even like old network tools, or even not network tools, like let's say Excel 2000. Remember when you went to open a large Excel spreadsheet off the network and it would freeze as it copied the whole file down? When Bro is doing all these things like extracting and analysis and hashing, it handles all of these things in an incremental fashion. So essentially what we have is you'll have like the network and you're downloading files over HTTP. All of these analyzers that are built into Bro process these files incrementally. So you're not going to DOS Bro by downloading a 5 gig ISO or something like that. So as you download that first piece of the file, you get the first piece of the SHA-1, or the first piece of the extraction, or the first piece of whatever. And as you continue to move through that process, you continue to handle these things incrementally until you get the final hash there, and then that would be saved out. So there's all of these analyzers that you can build right into your workflow. And we're not even talking about scripts like we're about to demonstrate, or the Team Comrie hash registry, or the other one. To have Bro automatically hash all the things. And I do want to point out that Bro's not just a network protocol analyzer. So these are essentially file protocols that are in Bro. You can point Bro at a file directory and have it read in all the files that are in that directory. Seth Hall has a script up in his GitHub that actually does just that, if you're interested. Bro is a streaming analyzer in that traditional Unixy sense, that you can pipe things to it. I will sometimes point Bro at standard in and something else at standard out. So there's a variety of these analyzers out there, and there's more coming all the time. So this is the favorite part. This is the demonstration. We're going to talk about writing some code, and I'll show you guys some use cases for this stuff. So when we're looking at stories, it's helpful if we have a story that people are familiar with. So we'll start with the SANS 2011 Holiday Challenge. And if you don't do the SANS challenges that Ed and his team do, Ed Sudukas, you're really missing out. They spend a ton of time on these things. There's a great storyline around it. There's always interesting challenges. The 2013 one was just gigantic. So let's take a peek at the 2013 one and think about our 3 work products that we'd be delivering in our incident response process. And then we'll tune Bro very quickly in order to have Bro help us create those 3 documents quicker. So the first thing that we're going to do is, let's see here. I've replayed this PCAP through Bro, and by default, Bro has this understanding of directionality and locality, and it uses those concepts to generate some of these logs. For example, Bro will, by default, only look at the things that are local and log them to known hosts. And there's a similar thing called known services. And it shows you, what are all these services that we've seen over, this period of time. So from a forensic point of view, normally you may not care what web server software my remote servers are running, but if you have a PCAP that you need to analyze from an incident, you may want to have all the details from both sides. So let's just log real quick how many elements are in each one of these key logs here. Let me pull up software real quick and I'll show it to you. So here's all like the software that was configured that Bro thought was local by your definition of local, which can include, not just RFC 1918 space. So if we said, okay, so if we just simply told Bro then to like this down here, to consider everything local, and then just replayed that PCAP through, we get a different answer, because now Bro will be, we'll just replay it real quick. All right. Okay, so already we can see that when we're generating those work products, that Bro can quickly be tuned to tell you a different answer. Now if we check out this particular PCAP, and again this is the SANS 2013 here, one that we're looking at, you'll see that we even have all the remote hosts, the web servers that were involved, if we considered this an incident, logged here very quickly. So when we're creating things like our like our map of the network, and maybe our list of hosts that were involved, I've now knocked out 2 things completely. They're done. I've got everything all listed here. And at the end of this, I'll show you how we can connect this and then make, like management level reports here in a second, okay? So this is now helpful because as an incident responder, I have probably 70 or 100 incidents that I need to knock out today. And, depending on your organization, you could have a different number. But I need to be able to move through these things as quickly as possible and as accurately as possible. So I'm going to build this workflow up around this. So the next demo that we're going to look at here is the 2011 challenge. And we're going to first extract all the things, and then we're going to look at those files, and then we're going to create a quick policy to give us some more context around that file extraction. So by default in Bro, if we ran that extract all the things right there, we'd end up with something like We'd end up with all those file IDs here. Let me show you some. So see these F numbers here in this column, right? Bro will call it, just save it out as a file ID. A common request we hear is, would you or could you use the file name to save everything out? Well, not every RFC component when you're transferring files actually gives you a mechanism to tell you the file name. For example, even in HTTP, the file name is often the URI that you're hitting. I want to download liamrandall.com/badstuff.exe. But it's not always. Badstuff.exe could actually be a PHP script that's executed by the server on the remote end, right? And threat actors realize that, and they mix those things up to confuse us as often as possible. So the first thing I thought it would be cool would be, what if we could do a bro script here? Irish dancing. Here's what we started with. Can you guys read that okay? Too small in the back? A little bigger? Okay, hold on here. I don't know the keyboard shortcut here in Sublime to make it bigger. View. I didn't think it was view. I thought I could go to like preferences and then there it is. Preferences, user preferences, and then you have to like reprogram it on the fly. All right, so let's just save that. There. Is that better or bigger? Yes? No, somebody said bigger? Bigger or smaller? One or two? Perfect. Okay, so let's move on. So here's our first bro app. Bam, we can extract all the things. Now, let's say we wanted to now examine those documents. I think it would be cool if we could tell Bro to name the files, maybe in a chronological order as the files started. So I want the first piece of my name to be 1, 2, 3, 4, 5, 6, 7, etc. Then the protocol they came down from, and perhaps even some additional protocol details. So for a given flow with our client and server here, please give me that image file. Okay, here it is. You could say that here's the files that came from the client, and then here's the files that came from the server. And then we could look at these things. So I went ahead and I just did the 3 steps here in my development process to generate that. And the first one, I started saying, okay, if you're familiar with like string substitution here, that's essentially what we're doing. I said, okay, we'll first call it source. So source would be like HTTP, FTP, IRC. And then file ID. And then this script just evolved a little bit here to add a couple if then else's. And let's look at the work product, the actual script out on the disk. So now I'm replaying these incidents, and suddenly now I have the ability to have all my files out here named in order. So here's my post and response. So let's see what that would look like if we were using, like Mac Preview here to sort of understand the SANS 2011 PCAP. Remember, this is our sample incident. There's been something. I extract a PCAP. I take a look at it. And let's see now if we can't tell that story, or how quickly we can tell that story compared to normal. And I'm surprised that people don't win these things quicker, because I'm now 60 seconds into my IR process, and let's tell a story real quick. Okay, so there's an email here, and I'm zooming in, and I know this PCAP pretty well, so I could see that it's SMTP here, and then the file ID. Okay, let me come up here. Oh. I can mouse. Hold on. Bro, do you even mouse? All right. Okay. All right. So we have an email here. Right. So here's my timeline. Somebody sent an email. Here was the attachment. They were viewing a web form to determine if they were on the naughty or nice list. All right. They requested the fave.icon. That wasn't there. Hey, there's the post request from the client to the server. Right? Think of it like a document. Right? The client hands the server a file and says, "Here's my document that I want you to process." So the first they said name equals grandma. And then there's the response, right? And then they said name equals cousin Mel. And Mel is also on the naughty list. You see that there? Mel's also on the naughty list. So what do you think that grandma's going to do next? She submitted a single quote, right? You can see it down here on the syntax, right? And then she submitted name equals show databases, right? Anybody want to guess what we're seeing now? Right? Right? And there's the response that grandma saw on her other side, right? So for me personally, when I started to think about networks then as just like the incidents as files, like I'm at this meta layer, I was like, oh, I think I have a better understanding of how SQL injection actually works now. I didn't think about it like this before. And we'll take this to the next step after this. Let's just go through the rest of this. Show tables from my DNS. There's the tables that are there. Show columns from my DNS. There's the columns. Blah, 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 blah. Show columns from my DNS again. Right? Select star from. Right? Insert into my DNS, and so forth. And they continue to go through the SQL injection. So you're an incident responder. You are not even done with your first cup of coffee, and you're about to clear out your first ticket. Incident confirmed. Check, move on to the next one. Right? That's ultimately what this is all about, right? You need to be more efficient, you need to be more productive, you need to be more accurate. So in this particular case, we use Bro to change the percentage of that full PCAP that we're extracting. And we said, okay, Bro, instead of only extracting the 1% meta layer here and just giving me a log line, also pull out all of the files that you see and save them out to disk in this helpful naming category that I can then browse to see what's going on. Right? And we go through the rest of this. I think we'll see there's more SQL injection, more SQL injection. This is now where the client gets compromised. They basically insert a record into the DNS database. Here, I'll show you. Whoa. Not wrong way there. All right. All right. Oh. All right. The threat actor in this case was the DNS traffic was not in there. But we could see from the files.log that the user eventually is tricked into downloading a Trojan executable from grandma's computer here, and then infects themselves, throws a reverse shell that grandma uses to access the computer. So seems like a pretty helpful thing to do. So I'll also post that script I used to dump all the names there. So what if we took it to the next level then and said, well, when I'm looking through these documents here, when I'm looking through these, I see a lot of SQL-like words. Like, what if we just told Bro to count anything that looked like SQL, right? So on these post documents that the server's handing up to us, right? Here's a document, here's a document. Let's just scan them all the time and look for, if we think of it like a series of elements, and just look for SQL commands. And maybe we should also watch our servers and look for things that look like MySQL, and things that look like Postgres, and things that look like Oracle, and things that look like Microsoft SQL Server. So anybody have an appliance in their rack that does like a web application filter? Can you get in there and monkey around with these things like this? Right? This is this power and perspective that is available. All right? We're not out of time yet, are we? Okay, we're good. Maybe, if I can figure out what I'm doing wrong there. Okay, all right. So let's look at the Bro policy we could use to scan it, right? So what I did here is I just created a list of all of the SQL-like words, like from and where, and order by and group by and union. And for the purposes of our demo now, I'm going to ask Bro to simply show me to print out to screen, how many elements are in that sample. And maybe we put a sanity threshold for a given application and say that, if maybe only count when there's more than 3 things present. And if we hit a total of 20, then we know we've got SQL injection. Right? That's a quick little policy we could use to implement that kind of scalable logic and workflow. So in closing, I just want to add that to the blue guys, we've been on this trend for the last 20 years of getting our asses handed to us big time, and we are slow because we're depending on appliance manufacturers to put these things in, and that that there are these tides in the affairs of men, and that the trend can never continue in one direction indefinitely. And the reason why I have such a real passion for coming out here and showing this, and if you've ever talked to me, Coleman, how many times have you heard me say the word Bro? More than 9,000? I think more than 9,000. Is that what you wanted to say? Something like that, right? Is that, this technology gives us the ability to be scalable and flexible and fast, right? Those guys over there have Meterpreter, and they've got Rapid7. And we get Bro now. So I'll go ahead and open up the floor. I think we've got 2 or 3 minutes for questions here. If anybody would like to ask a question, go ahead in the back.
So Bro, does the IDS stuff, is there ever a use case to turn it into a preventative mechanism?
Into a what mechanism?
Preventative mechanism.
So the question is Bro does the detection, has the detection capability. Can you turn it into like an active response product? Yes. There's a developer out at Lawrence Berkeley National Lab named Ashish Sharma, and he's worked very closely with the team. And for over 5 years, they've had Bro deployed in the active response, where Bro actually reaches into the network infrastructure and reprograms it on the fly. Those scripts are up on GitHub on multiple repositories. There's different versions. There's a coming Packet acquisition and control framework to Bro that has a plugin architecture that allows you to, sort of generalize like inserting ACLs, redirecting flows, and then gives you plugins for like Arista, and I think there's going to be a Cisco plugin, an OpenFlow plugin, and so forth. So that is sort of so it works now, and it's going into Bro as like a core feature in the near term. Questions? Yes. So the question is that he's in a situation where he's handling 30 million queries to web servers a day. That's no problem for Bro. For a long time, Bro has been the only choice on some of the fastest networks on the planet. For example, the first 10 gig Bro cluster was deployed in 2007, I think. The first 40 gig Bro cluster was in 2011, and that's 40 in each direction, guys. The first 100 gig Bro cluster is under installation now. Now, it doesn't make a ton of sense to just talk about, say, well, it's 100 gig this or a 40 gig that, because when you're looking at Bro. When you're looking at Bro or these other solutions, it's, what are you doing with it? You've got a multi-dimensional mapping. It is megabits per second, and traffic would be mapped to an X number of CPU cores on Y number of boxes, but then there's also this Z-axis of what policies am I running, right? But I would say no problem. Other questions? Keith? Yeah, absolutely. You have, obviously don't get the file size till the end of it. There's a guy named Mike Reeves, a pretty sharp guy in Cincinnati, and he has a set of Bro scripts that he runs right now where he extracts everything, every file, and then at the end when he gets the hash, I think he's keeping all of the distinct or unique files that he's seen on his network segments for particular file types. So that is another good use case. Other questions? Gentlemen, there is never enough time for anything, and I sincerely appreciate you spending some of your day with me. I'm available at Hectaman online. Critical Stack is the company I work for. IRC and IRL, I look forward to meeting you guys in the near future. Thank you.